need to understand if we're going to develop an overall understanding of the physiology of water and water balance and why water is so important to physiology, to pathophysiology and to clinical interventions, is osmosis. We need to understand osmosis. And osmosis really is a special sort of diffusion. Osmosis is diffusion of water through a semi-permeable membrane. So when we considered diffusion, we looked at the movement of a solute molecule through a solvent. So a solute is anything that is dissolved in a solvent. And of course in biology, that solvent is always going to be water. And in diffusion, we noticed that there was movement from high solute concentration to low solute concentration. Well, osmosis is the same. There's still movement from watery areas to less watery areas, but osmosis is only talking about water, the movement of water. And also, for there to be osmosis, there must be a semi-permeable membrane involved somewhere. Usually it's a cell membrane. So a semi-permeable membrane is just that. It is not permeable to everything, it's only permeable to certain things. And the thing it has to be permeable for, of course, for the movement of water, is it has to be permeable to water. So a semi-permeable membrane will allow water to move back and forth through it, but not other things. So let's consider a semi-permeable membrane. So here we have a membrane, and what we notice is there are small gaps in this membrane. There's a small gap here, another small gap there, another small gap there, another small gap there. Now let's think about the situation where we have proteins and water together. So let's imagine that there are proteins on this side of the membrane. So obviously, if we're talking about plasma, we know plasma contains plasma proteins, particularly albumin. And we also notice that the proteins are very big molecules. Proteins are large molecules. Molecular weights well into the thousands. Whereas water is only H2O, so it's a small molecule. So in the plasma proteins, we have lots of smaller water molecules here. And on the other side of the membrane, we're also going to have water molecules over here. Lots of water molecules. So here we have plasma proteins and water molecules, whereas here we just have water molecules. Now, what we notice here is that even though the pressure on both sides of the membrane is the same, there's water molecules here and there's water molecules here. But on which side are there more water molecules? Well, given that the volumes are the same, I think you can see that there's more water molecules on this side, because a lot of the space on this side is taken up by the plasma proteins. And these are big molecules. It's like if you had a room with lots of people in it, but several elephants in the room as well. Because the elephants are very large, that means there's less space left for people. And it's the same here, because a lot of the space is taken up by the large plasma proteins, there's less space left for the water. Now, osmosis is movement of water through a semi-permeable membrane from a watery area to a less watery area. So if you remember nothing else about osmosis, remember this. Osmosis waters down. Osmosis is like a waterfall. The water's going down. Osmosis waters down. It is a dilution effect. and there is movement from this watery area to the less watery area. So given that the plasma proteins are the solute molecules, that means there's going to be movement of water from an area of low solute concentration to an area of high solute concentration. So we could say that osmosis is the movement of water from an area of low solute concentration to an area of high solute concentration through a semi-permeable membrane. Now, why does this happen? Why is it that these molecules move in this direction? Why are the molecules moving from the watery area to the less watery area? And the answer to that question is actually diffusion. Because if you think about it, diffusion is the tendency for substances to intermingle when brought into contact until their concentrations are equal throughout. And the water can move freely, actually. These water molecules here can move through in that direction. And these water molecules here can move through in that direction. And we know that these water molecules are vibrating because of kinetic theory, so they're going to be moving. And diffusion, it says that substances should equal out until their concentrations are equal. And we have a higher concentration of water here than we have here. So the water wants to diffuse until its concentrations are equal on both sides of the membrane. The water wants to diffuse following this principle of diffusion. So while some water molecules may well move from that side to that side, the net movement is going to be the watering down effect as the water, as it were, tries to get the same concentrations of water on this side of the membrane as on this side of the membrane. So the net movement is the water molecules going from the watery side to the less watery side. There is a movement. And that movement will occur with a particular pressure. And that pressure will be determined by the amount of these solute molecules on this side of the membrane. And this movement of water will amount to a pressure, and that pressure is called osmotic pressure. So water moves from the watery area to the less watery area, diluting this area under the influence of osmotic pressure. So remember, osmosis is a dilution effect through a semi-permeable membrane. Watery areas will dilute less watery areas. There will be net movement of water from areas of low solute concentration to areas of high solute concentration.